Welcome to qnawire.
So in part A of this question, we're going to sketch a graph or a potential graph of this function given this information. So part A, first thing is I'm just going to draw a graph. And so we're told that at f of 3, we have this point at 3 comma 2. So we have a point here, 3 comma 2. And we're told that f prime of 3 is equal to 1 half, so we're increasing, we have a positive slope. And we're also told that f prime of x is always positive and f double prime of x is always negative. So if f prime of x is always positive, that means that we're always increasing. And if f double prime of x is always negative, that means that we're always concave down. So we just need to have a curve that is both increasing and concave down that goes through this point 3 comma 2, and that will be a good sketch of our graph. And now for part B, what we're going to do is figure out how many solutions or how many zeros our function f of x has. So how many solutions are there to f of x is equal to 0? Well, if we look at our graph, we know that we're always increasing. So there's no way that after this point we're going to somehow go down and then cross the x-axis again. We're always increasing. So the only time that we could cross the x-axis would be before this point 3, 2 at some point over here when we're in this concave down area. And so we can only have one solution for f of x equal to 0 since we cross the x-axis once and then we're increasing forever. So we're never going to go back down and cross it again. So there's one possible solution to f of x is equal to 0. And now for part C, we're going to figure out if it is possible for f prime of 2 to be equal to 1/3. Well, let's go back and look at the conditions we were given originally. So we're told that our derivative is positive everywhere. Well, the derivative here, f prime of 2, is positive. It's equal to 1/3, so that's good. And we're also told that the second derivative is always negative. So we can also think of this second derivative as just the first derivative of our f prime of x. So it'll tell us where we are increasing or decreasing based on if we have positive or negative values. So since we have only negative values of our second derivative f of x, f double prime of x, that means our derivative f prime of x is always decreasing. So we can't actually have f prime of 2 being equal to 1/3 because if our derivative, as it should be, is always decreasing, then f prime of 3 would not be equal to 1/2, it would be equal to something less than 1/3. Since 1/2 is greater than 1/3, that would mean that our derivative actually increased, which is not in line with the conditions we were given. So it is not possible for f prime of 2 to be equal to 1/3.